Railroad iron is a magician's rod, in its power to evoke the sleeping energies of land and water. Ralph Waldo Emerson. Iron was a factor that influenced the Industrial Revolution and was an important building block for railroads and steam trains. There were a number of steps that the people had to go through in order to create iron. In early times, the materials needed were charcoal, iron ore, a furnace, and a hammer. First, the pure iron metal needed to be separated from the iron ore in a process called smelting. The iron ore would be placed in a fire fueled by charcoal in a furnace. The fire would be hot enough to melt the iron ore. Pure metal would flow out in molds called pigs. These pigs would be hammered into sheets. The way iron was made started to change and improve in later times. In the 1600s, instead of being hammered into sheets, they were rolled into sheets at rolling mills. In the 1700s, wood became expensive because of a lack of trees. Some companies died because of how expensive it was. A man named Abraham Darby, who was a Shropshire iron maker, introduced coke to the iron business. The coke was created by heating coal in an airtight oven. This coke was cheaper, but some iron makers complained that iron made with coke was too brittle and hard to work with. In 1750, his son, Abraham Darby II, improved the method of using coke. The coke iron was no longer brittle, so, after 1760, coke iron started to spread throughout Britain. Another improvement made to the iron business was the grooved rolling iron. This made it possible for iron makers to mold the iron into different shapes. The grooved rolling iron was introduced in the 1720s. Henry Court, a Fareham iron maker, further improved the grooved rolling iron in 1783, and he also invented the puddling furnace. The pig iron would be put into the furnace to be reheated. After this, it would be turned into a type of paste. The iron maker or puddler, if he were to use this method, would stir the paste with two metal rods, which would eliminate more of the impurities or pieces that were not pure iron to make it stronger. Iron was used to create machine frame, steam engine parts, water pipes, railroads, and other products. As the strength and production rate of iron increased, the strength and rate of production for railroads and steam trains also increased.
The creation of the steam engine greatly influenced the Industrial Revolution, helping to quickly advance many industries such as manufacturing and transportation. Before the steam engine, many factories were limited to being powered by water, wind, and animals. Factories had to be located close to rivers or in windy places, and could only run when the water and wind flowed quickly and strongly. Animals had to be taken care of and could only work so long before they became tired. People had to move out where the factories were, or they had to live in dormitories. Mines were shallow because of the water that filled them. Once all available materials were stripped, they were abandoned. In order to go anywhere or transport anything, one would have to rely on animals. There were railroads, but the cars were horse-drawn and had almost no advantages over regular carriages and roads. In 1698, Thomas Savery invented an inefficient prototype steam engine, which he said raised water by fire. Savery's design was improved by Thomas Newcomen in 1702, when he added pistons and cylinders. Newcomen's 4-horsepower engine was used to pump water out of mines. Newcomen's design was further improved by James Watt in 1769, who increased the efficiency to levels appropriate for manufacturing use. Further increasing the steam engine's suitability to be used in factories was the planetary gear. A planetary gear took the back and forth motion of a piston and converted it into rotary motion. Watt, recognizing the uses and subsequent fortune he could make from steam engines, partnered with Matthew Boulton, a British manufacturer. Together, they successfully produced and marketed the steam engine to nearly every industry.
I sell here, sir, what the world desires to have. Power. Matthew Boulton.
Indeed, the world did want the steam engine, and Boulton and Watt amassed great fortunes because of it. Part of Watt's ingenuity was to measure the power output of his engines in a new unit he called horsepower. Although steam engines were nowhere near the size or efficiency of today's engines, at around 2 stories high and only producing 45 horsepower, they revolutionized industries as we know it. Factories no longer had to be next to rivers, and they could locate closer to towns to get more workers, or even out in more remote places closer to the materials they needed. Work could continue year-round and at a much more constant pace. Steam engines eventually advanced enough for them to become small and light enough for trains to use. Robert Fulton also wanted to apply steam engines to ships, and was relatively successful, as the coal-powered ships were more efficient and were much more reliable than the other ships of their day. However, They were limited to short trips, as the coal weighed too much for transoceanic travel, limiting their use until more advancements were made in size and efficiency of engines.
Before the invention of the steam engine, railways were powered by horses, and there were very few advantages over just using a normal carriage on a road. In 1804, Richard Trevithick developed the first steam locomotive to be just demonstrated publicly running on rails. It was called the Penny Darren. While this engine may look primitive by today's standards, it was a revolutionary new technology. Although it only ran at 12 miles per hour, the Penny Darren proved that steam power was a viable method of transportation and could be used as rail travel. One major drawback of the early steam locomotives was their weight. The immense weight of the locomotives broke the fragile iron rails. In 1829, a new design of locomotives came when the Liverpool and Manchester Railway in Britain organized the Rainhill Trials. This race was organized to determine whose steam locomotives would be used on the new railway. George and Robert Stephenson's Rocket won the trials. The Rocket's radical new design, seen here, made it the first modern locomotive in the world. All the critical parts were placed in virtually the same orientation for almost 100 years until the invention of diesel and electric locomotives. Along with the new innovation in locomotives, new wrought iron rails were much stronger and can finally support the heavy trains. With both the new locomotives and the new rails, a rail mania was triggered in both the United States and England. George Stephenson himself once said, "The rage for railroads is so great that many will be laid in parts where they will not pay." The train and railroads had clearly become a mainstay in the Industrial Revolution, and tracks were being laid everywhere. During this rail mania, thousands of miles of tracks were laid all across both America and England. One problem with all these different competing railway companies were the gauges of track. A lot of times, different companies built their track in different widths and had their own custom-made cars and locomotives. This meant that in order to, say, get from one end of Britain to the other, you may have to have changed trains many times because the track was not in the right gauge. Eventually, however, everything was standardized, and rail travel became a lot easier. By the 1850s, trains were carrying millions of tons of cargo and hundreds of thousands of people every year. The golden age of railroads had begun.